Hello everyone, it's really nice to be in this beautiful city. I already had the pleasure of trying some Hungarian food. I'm still digesting it. It's amazing. Yeah, it's amazing. Let's get going. So I want this talk to be a bit interactive. So if you have any questions, feel free to interrupt me during the talk. Just raise your hand and I'll engage with you so we can talk about stuff. And yeah, let's talk about stuff today. So I want to talk about type-safe database access with Node.js and TypeScript today. A little bit about me. My name is Divyendu. I come from India, and I work at a company called Prisma. At Prisma, our slogan is that we make data easy. We are based in Berlin. On the internet, you can find me on my handle, which is mostly Divyendu Z. I don't know why I put a Z there, but that's how it is. All right. This is the part of the world where I come from. So right on the foothill of Himalayas, if you're interested in knowing about India or about this place, just feel free to hit me up. OK, let's get into the content of the talk. How many of you use TypeScript here? Oh, that's a lot of people. That's super nice. And how many of you use TypeScript in production? So some hands went down, but then it's still a good number. And TypeScript gives you a lot of good stuff. So type safety, I would say, if I have to summarize it in a small sentence, it would be that bringing runtime errors into compile time errors is our goal. So instead of something failing for your user, it fails for you. And that's the goal of this thing. And we have some stuff that JavaScript does and some stuff that TypeScript does. And here we've mentioned that JavaScript does not provide you type safety or faster refactors, and TypeScript does that. But TypeScript does not run without a build step, so there's some sort of complexity. However, the ecosystem is working very hard to make this barrier be small. So for example, you can get TypeScript benefits in JavaScript by just using one small comment on top of your file. So my demo today would be actually in JavaScript, but we'll get a lot of benefits of TypeScript in it. And TS Node, for example, gives you the benefit of building TypeScript with a single build step. So the ecosystem is like coming close together nicely. I'm here to talk about Prisma, which is the company that I work for. Has any of you heard about or used Prisma before? Nice, amazing. Let's talk after the talk is over about stuff. So what is Prisma? For anyone who doesn't know Prisma, it's a database toolkit that helps you manage databases. Like, it abstracts databases away. It is a database toolkit that helps you do data modeling and migration, and it helps you write applications faster by giving you a type-safe database client, which is the topic for today. So all of that is good, but why should you care about a tool like Prisma? So it gives you a client that's generated for your business domain, and it helps you write code faster with more confidence. It has great docs for whatever stage of developer journey you are on. So if you're an individual developer, it targets you. If you're a small team, we have workflows for you. And if you're an enterprise, we also support you. And then you get the benefits of TypeScript in a Node.js application, as I show in my demo. But TypeScript is also a first-class citizen for us. All right, to get started with Prisma today, all you need to do is run this command, and you have the Prisma CLI, and then you can move forward. Moving on, at the core of Prisma is this thing which we call Prisma Schema language. Prisma Schema language abstracts your database into this thing that represents your model. So you can have a user table, and that would be represented like this, and a post table, and that would be represented like this. And the first question that would pop up in your mind is, how do you get such a file, or what does this file represent? So the white things in each model are fields. The pink thing is its data type. And then we have directives which define something as an ID or a unique field. So it essentially represents your database in a declarative language. We also have this thing running in our community where people say that what React is for UI, Prisma is for databases. So the first question that would come to you is, how do you reach such a file? So if you're starting a new project, you can hand type that file and migrate your database using Prisma. So you write this file out, and Prisma writes the SQL for you. Or if you're coming from an existing project, you can introspect your database, and we produce this file for you. So that would be something that we show today in the demo. All right, moving on. And once you have the Prisma schema file, you can run Prisma generate command, and it gives you Photon, which is our type-safe database client, and it can and you can do data query based on it, and based on your query, it produces a type-safe result. So, for example, in this case, you're selecting ID and name, but you're trying to access email, and that won't work, and your code would fail at compile time. So you would know much earlier in the development process that something is wrongly accessed. So no more undefined is not a function or those kind of things. And I would just mention that the name of this tool, photon.js, is set to change soon. So if you check out Prisma in a couple of days, maybe, you might find Prisma.js client, but that's the same thing as photon.js. We're just renaming it. Yeah, and how we do this is pretty interesting. There is a link that's unfortunately behind me and also there. It's about how we do this thing. We generate this client using a lot of code generation and conditional types in TypeScript, and that's a very interesting topic. And that link points to a talk from one of my colleagues, Tim Sukanek, about this topic. If you want to go into a deep dive, and don't worry about noting it down. I'll present the slides after the meetup. And this is all the context of what Prisma does. I want to talk more about how does it provide value to you or your workflow. Let's talk about changing a field in your database. So in a traditional workflow, what you do is that you add or remove columns, and then in your application code, you go and you make changes everywhere. So for example, you are renaming name to first name and last name. You'll have to go and remove all references of name, and then replace it with first name and last name. The problem with it normally is that your code does not help you. So a lot of times you run into stuff like this, which is like you reference name, but it doesn't exist anymore. And this is a runtime error. And the summary of this thing is that runtime errors are bad and compile time errors are slightly better. And we want to move from runtime errors to compile time errors. And that's what type safety is mostly all about. The workflow with Prisma would look like this, that you alter your schema.prisma. Somehow you can manually change it, or you can introspect it, and then you run Prisma generate, and you get a fully type-safe database client, and then all of your database mismatch thingies are now a compile time error. All right, it's demo time. So let's pray to the demo gods first. If I'm not audible, I've kept the mic there. Just please let me know. And oh no, I don't have an escape button. All right, for the purpose of this demo, I'll use a very small database. Like assume that you have only one table, and that has a ID and a name field, and it has some data in it. And I would start with an existing application that uses MySQL, and we would convert this to a Prisma application, kinda, and we'll see the benefits of using Prisma together with it. And this boilerplate gets the ID and name from the user table, and then fetches the relevant fields from it and prints it out. So if I run this, it just prints the data as we expect it to. Now, if we want to convert this project into a Prisma project, we need the schema.file first. And to do that, we can run the introspect command, and I can do yarn prisma to introspect, and then I can give it my database credentials. And it tells me that it has printed a schema.prisma for me. Let's go through that for a moment. So it has this data source DB, which has your database credentials, and it has your model, and it matches what you have in the underlying SQL, so ID and name, and it could read that and print this thing in. And the next step for us would be to run Prisma to generate, and it will tell you that, okay, your file doesn't look incomplete. Your file looks incomplete. You need to add this thing to write and generate the client. So we do that. And then we run it again. And it tells you that, okay, this worked. Wow, nice, perfect. And now I have my client generated, and I can start using it. I go here, and I do const photon equal to require at, oops, Prisma/photon, and then I can initialize photon like this. And then let's try to do the same thing that we're doing with MySQL with Prisma. So as you see, you get the auto-completion for your business domain. Like this thing did not exist, but now you get users field on this, which comes from your database. And you can do, say, find many, and then you can tell it to select the ID and the name field. And you can console.log that. Oops. OK. And you see that the type of this thing is already filled, and we convert this dynamically into the generated TypeScript type. And that's a very interesting topic. So the link that was there in the previous slide talks about that topic in great depth, and feel free to talk to me about this as well. Let's explore the use case of. Yes, please.
A single question. So how do you solve this type providing or type safetiness behind under the hood? Because what I was expecting is it's going to be partial of users. It actually told the correct type.
Yeah. So this is a feature of TypeScript called conditional types. And what we can do is that we can read this object. If you go deep into this, we have the args, which is like a subset of find many user args. And then we are doing a lot of generation magic to figure out what is in select exactly. And we iterate over the types of the select object at runtime, and we produce the type out of it.
That's because you're using types.
Yeah. Yeah, exactly. And we are generating it for each model. We have the information when we are generating the thing. So instead of doing one generic thing that can be used for all the types, we print it out for each model separately. Yeah, let's talk about that more soon. All right, so moving on to the example that we spoke about, let's try to see how altering a database field looks like in a traditional workflow versus using it with Prisma. And that's when I go to a nice little helper, and I copy some code. So it's very simple. I'm just dropping the table column name, and I'm adding two new columns, first name and last name. And once I run this and I refresh, I see that I have this new thing. My name is gone, so I'll just add a new name again, Alice. Oops. Something weird happened with table plus. One sec, please. That's table plus, that's not Prisma, so I can just bulldoze my way through this and it's fine. 3, maybe, Alice, Prisma, works. No data. I'll just restart table plus. No, table plus, don't do this. All right. That's a lot of databases. Budapest.js. User, oh, I have data, sounds good. I'll just get rid of this thing, and now we are kind of good. And we're back. So we have changed our structure, and now we need to introspect our database again. When you're developing, your build step or your migration step would have this, so that this happens automatically for you. So you just need to run this command whenever you are migrating, or anyhow you are migrating, and that generates the schema file for you. And we can see that it moved the existing schema file to schema backup and wrote a new schema file. That's one hiccup. We don't want to do this. In future, we would want to print one file and use Git. The second hiccup that would happen here is that we are actually removing the generator part of this again. So the CLI would fail. We'll fix that so that it prints that one line again. And I can just bring it back right now from my awesome clipboard tool. OK. So now you can see that we have found out that the database has first name and last name now instead of name, and we have printed that for you. And you can run generate, and fun stuff happens. So if you go back into your file, you know that your old SQL stuff doesn't tell you anything. This would have been a runtime error unless you manually go and change it in all the places. This is a very small example, but in bigger applications, this is something that's easy to miss. But Photon fails for you at compile time, and that's really good. So I get rid of all the other code, and now we know that name is incorrect, and you get type completion for stuff. So you can select the new things. And you can run it, and it accesses the data for you, which is in the database. And I guess that's all for the demo. We can move on.
Can we get back to the model schema?
Yes, please. Yep. This one?
No.
In my code? Yeah, sure. There you go.
Yeah. ID is actually a string, right? Not an integer.
This ID is a string in this case, yes. Yep.
I was just wondering whether we can put there some integer.
We can, in this case, I think the underlying structure has UUID, and that's what the introspection is picking. But if it's an integer, it would pick integer. So, an integer is a valid type in Prisma.
Confuse the system. The client.
So you.
If I put there some invalid due to the speed,
so
which is inside the model user.
So it depends on how are you doing it. For example, if you're introspecting, it would put the right thing. But if you go and change it to something else, then there.
It can break the JavaScript code in the middle, in the point.
Yeah, for sure. So it won't break the JavaScript code because variable coercion will happen. So it will try to convert stuff. But
if smart coercions, but
yes, but we won't let it happen at all because there is a layer of Rust code that powers Photon, and that's where it will surely fail, and it will give you an error that, okay, you're trying to get this value from database, which is a string, and you're trying to make it an integer, and that's wrong. Please fix your data. So that case is sorted. It will never hit JavaScript part of our thing. That's an abstraction, so we did not speak about Rust at all, but Photon internally uses a Rust binary, and for anyone that's interested, we can talk about that. Yeah. All right, that's for the demo, and I would like to ask if anyone has any questions about this thing, or if I should move on. All right.
Are there any transactions in Photon?
So yes, we do not support a traditional database way of doing start transaction and then do stuff and then end transaction. We think that that's an anti-pattern for databases because transactions are very heavy. If you want transactions, we allow for short-lived transactions as nested writes or relational operations. So if you, right now we just saw a read operation, but you can do a write operation, and you can do write operation on relations. And if you do that, then that's a transaction. So that's the only form of transaction that we offer right now. There is an open issue about future of transaction API, where our current stance is that that's like sort of an anti-pattern. We don't want you to have that, but if enough people want to have that, then we'll build that. So please chime in with your ideas on that one. Yeah. All right. Yes.
So I would have a question regarding to the, let's say, the further functionality, because what I've seen so far is pretty impressive. We are using TypeORM in our Node.js code, and this actually looks like much more handy. But how did you solve, or how deeply you solved problems with nested fields, like many-to-many relationships or many-to-one relationships, like joining tables and such?
Yep.
Do you have that kind of pretty nice notation which you did have with select?
Yeah, sure. So let me answer that question. So I kind of lied when I said that Photon is an ORM because ORMs have these kind of problems. Photon is not really an ORM. Photon is actually internally a query builder. What's happening is that internally we are starting a Rust binary that's a server, and it's a GraphQL server right now. And Photon builds a GraphQL query and sends it, and then it gets resolved. So relations are resolved in GraphQL server land. We are producing a GraphQL server, and in future this becomes a Prisma query language server, and we take GraphQL out and we bring something in that's like tailored to databases, but it's essentially a query builder right now.
Oh, I see.
Yeah. And that's where it supports deeply nested writes, multiple join tables, and other things in the beautiful land of APIs that we have designed for you. Yeah. All right. Okay, moving on. So in the very near future, like that's one of the most important slides that I have today, we are going to be production ready soon. So whatever I showed to you today is not production ready yet. We are gearing towards it, and please follow @Prisma on Twitter for it. Please join our Slack. Feel free to talk to me after the talk if you have any questions. Join the Prisma 2 preview channel. That's where all the stuff is happening. And then we also have a migration system where you can write your schema with hands, and then you can perform migrations on it, or you can introspect a big project and then change it and then start migrating it using Prisma instead of using your existing migration system. So all of that happens in Q2. So that's one of the things. So we want to incentivize people for trying it out because we are closing to the launch. So there's a small thing that we're doing that if you introspect your database with Prisma and you try to use it, it'll probably break right now. We know that because internally in our system we have like 300 databases and we are trying it out on everything. So we know there are shortcomings. But we want to be production ready in Feb. So if you try it out and raise an issue and talk to us, like you can talk to me on our Slack or anywhere in the internet, and if you do that, we'll send you some swag. And that reminds me that I have some stickers with me today. If anyone wants, just talk to me and I'll get them for you. All right, and then the customary slide that we are hiring. If you're doing TypeScript or JavaScript, please apply to us. If you are in doubt that whether you should apply or not, please apply. That's the right choice. Yeah, I guess that's all. Join our community, talk to us, slack.prisma.io or prisma.io. We're doing a lot of amazing stuff in TypeScript, Rust, and a lot of different languages.